So this is a review of exponential and logarithmic derivatives. Okay, so recall that if we have e to the x, the derivative of e to the x is just e to the x. So we can write it this way: d dx of e to the x is just e to the x. So the derivative of e to the x is e to the x. Now, let's look at another one. How about the derivative of 1 over x? The derivative of the natural log of x. This is 1 over x. Now, there's another derivative I want to take a look at. The derivative of a to the x, where a is not e. A is any number at all, any constant at all. This derivative is a to the x, natural log of x. All right, so I'm going to ask a question. Why is this so? I want you to go back to your Calc 1 and tell me why and figure out why. Some of you might know. Maybe you tell me how to do it in class. Okay. So, for this reason, we can now figure out certain integrals. So I can say consequently, the integral of e to the x dx is just going to be e to the x plus c. All right? So remember this, the integral of e to the x dx is just e to the x. And this is because the derivative of e to the x is e to the x. All right? Now, secondly, the integral of a to the x. Or let's do the integral. This one we know already, but let's do it again. 1 over x dx is natural log of absolute value of x plus c. And then the big one, the integral of a to the x dx, or the antiderivative, is 1 over the natural logarithm of a, then a to the x. All right. So let's put this in a box, and then these are very important. Oh no, I just want it in the box, that's all. Okay, so let's do some examples. We're going to say evaluate each integral. So the first one is the integral of x squared e to the x cubed dx. So if you pay attention to our discussion on substitution, you can see that this is clearly a substitution game. Why? Because we have e to the x to the power of 3. X to the power of 3 is right here, right? And its derivative is 3x squared, and x squared is sitting right here. So let's go ahead and make u, let's use green. We're going to say let u be x cubed. If this is the case, then du dx is 3x squared, so that dx is du over 3x squared. Alright, so that when we come back here, we plug in our u's and our values of dx. So we have x squared e to the u. Instead of dx, we now have du over 3x squared. So things are going to cancel out. This and that are going to cancel out. And then we can bring out 1/3, and we're left with e to the u du. The derivative of e to the u is just e to the u. So this is, the integral of e to the u is just e to the u. So this is 1/3 e to the u plus c. But then e to the u is, u is x cubed. So this is x cubed plus c. All right. Let's try another one. Let's try a second one. Let's actually, okay. I'm gonna try a few. Number 2. Let us do the integral of e to the x over 1 plus e to the x dx. So if you notice, we can take our derivative to be, we can take our u to be 1 plus e to the x. Because if we do so, its derivative is just e to the x. So if we say let u be 1 plus e to the x, then our du dx is 1 plus e to the x. No, our du dx is just e to the x, its derivative. And this means that our dx is du over e to the x. And we have an e to the x sitting right here that we can cancel out with. So we go ahead and we rewrite everything in terms of u. So we have e to the x over u du over e to the x. So they're going to cancel out. And then we are left with integral 1 over u du, which is, I like to write on one straight line like this. I'm not wasting any paper, so I'm good. So we have this is natural log of the absolute value of u plus c, and this is natural log of e to the x plus 1 plus c. Remember, our u is e to the x. Our u is 1 plus e to the x. All right, let's try a third one. And this third one is a fact that we already stated. So we're going to try to show that this is actually true. How is this true? All right, let's copy it. Okay. So let's try this problem right here. Okay. So we have no choice but to begin by saying let u be, let our u be equal to a to the x. So if you remember, a to the x, the derivative of a to the x is a to the x natural log of a. Whoa. I screwed up here. Sorry about this. This is a no-no in a recording. Actually, I'm gonna write it in green just to make sure. Number 3 here, if you go back to the very first few things that we did, the derivative of a to the x is a to the x natural log of a, not a to the x natural log of x. Sorry about that. I am very sorry. All right. Okay. So we're going to use this fact. We're going to take the derivative of u, which is du dx, du dx now is a to the x natural log of a. I don't want to mess it up again. So that dx, it's going to be, let's see, dx is du over a to the x natural log of a. Okay. All right. Or we can actually think of dx as du over u natural log of a. Okay. Let's see, how does that work in our integral? So this becomes integral u du natural log of a. See that? And then we have the u here, u natural log of a. Sorry about that. So I'm just substituting what we have here in green into our integral. All right, so this is integral. Things are going to cancel out. And we have, if we can factor out 1 over natural log of a. Natural log of a is a constant. So we have du. So if you have du, this is like saying, oh, we're looking for the antiderivative of 1 du. And if you find the antiderivative of 1 du, you just get du. You just get u, sorry. So this is 1 over natural log of a times u plus c. But what is u? U is a to the x. So 1 over natural log of a times a to the x plus c. All right. So I just want to go back to the place where I messed up a little bit and re-explain. So this is the derivative of a to the x, where a to the x is not over here. A to the x is a constant, but a to the x is not a to the x is any real number at all, any constant, just a constant. So a is a constant. A is any constant. So my question is why? Why is this so? Let me rewrite it in blue. Okay. Now, do we need to do one more? Let's see if we can do one more. Okay, so let's try another problem. But before we try another problem, I want us to know that this solution is very, very useful. I already put it in a box, but I'm gonna put it in a box, in its own box again. See, its own box, this one. So I'm gonna paste it here. I'm gonna put it in a green box. And I'm gonna call it asterisk. Okay. So let's try another problem. Call it problem 4. About the integral of x 5 to the power of x squared dx. Now let's let our u be equal to x squared, so that du dx is 2x, and in that case, let's do and in that case dx is equal to du over 2x. Okay, so what do? This becomes integral x 5 to the power of u, and then du over 2x. Cross this out, and then we have 1/2 integral 5 to the power of u du. And then what can we do? We can just use asterisks, use our result from here. Okay, this result. So how do we use this result? We have a constant. We don't touch constants. This is integral of 5 to the power of u du. Is similar to the integral of a to the x dx. So it's just going to be 1 over natural log of 5 times 5 to the power of u plus c. So this is 1/2 1 over 2 natural log of 5. 5 to the power of u is x squared plus c. So that's our result. All right. That's the final answer. Okay. We're going to stop here.